Hey everybody, I just wanted to go over some of the changes to the vehicle base class as well as the vehicle module class. Quick description of vehicle modules is they are anything that can be spawned or configured on the ships, including main engines, reactors, weapons, sensors, propellant storage, or power storage. Anything like that will be considered a module and have a lot of the basic module data associated with it. Today I'm going to go over setting up the main engine module. We're going to call that the Pegasus Tier 1 main engine. There's some cool stuff, and I kind of want everybody's feedback on how they feel about the system. Does it seem easy to use? I'm trying to keep it as approachable and non and remove complication where I can. So I would like for anyone who's able or who needs to come in and make a tweak to something gameplay or design wise to be able to do so without having to reach out to tech all the time. Not that we don't like it, but you know. So yeah, we're gonna open up this blueprint, and one quick thing before we start is using curves is now a new way to manage the output data of certain things, whether that be over time or on a fixed scale. So I'll go over that in a little bit when we get to the applying the curves where they need to go. So if we open up the blueprint, there are some default components spawned here. We have a root. That's just basically, the origin for this little actor. You have an engine mesh. We'll go ahead and set that. Should be the same name as the engine we're making. Pegasus Tier 1 main engine. There we go. So this is our visual mesh. One thing we need to do is we're going to set it to have no collision. Don't need it to ever have any of this, any collision. We have a separate collision mesh to handle collision, and that doesn't need to be per poly, because this per poly would be unnecessarily wasteful resource wise. We just double check everything's good. Yes, okay, cool. So now we'll set up our collision mesh. This first. And PT1 main engine collision. Now we have. So this is obnoxiously green mesh is would be the component overlay mesh. So I think the current way you would have it designed is if the player holds down a key on their keyboard, controller, or joystick, they can see an overlay of their ship from their third person or drone view that would show color coded and the status of all modules or components attached to their ship. So in this case, if the engine took damage, this would fade from green being healthy down to a red, orangish color for damaged. And then if it is disabled or destroyed, it would turn into a dark gray. So this isn't ever seen in game unless you would hold the key to show it in game. So we'll just keep that turned off for right now because we don't have any way to show that, and that would take a while. So for now, we will just start by setting up the engine light. So it sits relatively where it should, kind of near the mouth of the nozzle. We're going to set some values on this. So with the main engine lights, there's only a few values you need to worry about. It's the attenuation radius. For an engine this size would be pretty large. You want the source radius to kind of match up to the mouth of the nozzle. I believe that was like 12. Yeah, that looks good. And we'll set the length to 15. So it kind of sits back in there. Looks kind of cool. And we'll make sure the color is set to match the amber that the emissive maps on the engine look like. That looks good. All right. Turn off cast static shadows. Cool. So now we need to get into the meat of the video, which is setting up the engine configuration section. But before we do that, I mentioned module data earlier. So right now the only two things we have exposed are module tag, which we will see is the Pegasus Tier 1 main engine. This will obviously be a better, more lore-friendly name when we get around to it, but I don't want to waste my time coming up with an awesome name for this engine right now. And then the operational status. Well, every module will have an operational status. So we'll have offline, startup, online, disabled, and destroyed. Cool thing about this is that this is when this value changes, there is an event dispatcher that will send a message out saying the new operational state of this module, or whatever module it may be, is now startup, is now online. So that's very useful for taking, if an engine was online and then gets destroyed, it'll send an event out with the new operational state, and you can then, if the operational state is destroyed, you're like, okay, now I need to play this sound and show this UI element to tell the player that one of his engines was just destroyed. So that'll be very useful going forward with a module system. We're going to default this blueprint to have it set to offline. I'll go over the whole startup thing at a later date when that's further developed. But right now it is not, so but that'll be a very cool feature coming down the road, especially for players determining what modules they equip to their ships. I feel like it's a pretty nifty design feature. Anyway, so power curves. Curves are the new bread and butter of this system. And just as an audio disclaimer, this should and will work with event parameters and RTC values in Wise. It's not using Wise right now, just so I can quickly get in here and set it up. But I will work with the Wise team and audio team to get that functionality implemented as they need it. So the power curve. So this controls the engine output value of the main engine, and we are going to use a pre-made Pegasus Tier 1 power curve. If we take a look at that, we notice that we know the engine operates on a 0 to 1 scale. So this happens over time as well, using the ramp up speed and the ramp down speed. So if the engine is throttling up, it throttles up a little more slowly. The lower the value, the slower the progress over time is. So as the engine's throttling up, it throttles up a little slower. When it ramps down or throttles down, it's much more abrupt. So that it's not instantaneous. It allows for some interpolation between the engine being full on going to full off, but it's a lot quicker than the ramp up speed. So those ramp up and ramp down speeds basically control how fast the progression of the engine output goes up and down this curve. So this will make it much easier to do more fine-tuned and precise maneuvers. So if you are to tap the W key or tap the forward movement value, it would only ever reach about, half throttle or a little less than a quarter throttle actually. So it'll allow you to move very precisely into for docking maneuvers and flying in formation, matching speeds with other ships, players, or objects in the world. Okay, so we have our power curve applied. Engine light, min and max. So the engine light's brightness is directly controlled by the power curve. So when the engine is at idle, it'll sit at 10. And when the engine is at full power, it'll ramp all the way up to 250,000, my bad. You won't really need to worry about max force, gimbal, min, max, propellant consumption rate right now. None of that's fully implemented, and but this would be the max force the engine can exert on the vehicle it's attached to. Then we have shake amount and stuff. So if we were to play right now with our current engine, we should be able to see the light work appropriately. Let's just drag one in. And we'll go to simulate. And I will, so the engine's offline, dragging this value, doesn't do anything, it just locks it to 0. That sound is the Pegasus startup sound in the back, don't mind that. So if we change the operational status to online, we get a notification up here, and then the light is sitting at its 10 value, very low. So if we drag it up, now have full throttle. There's some engine shake in there, pretty cool, but we can drag that down to 30%, 30. And it gets much, much lower. So now we're back at 0. Cool. Let's stop that, go back in and get some sound set up. This is the fun part. So I'm trying to figure out a way to easily manage audio, whether that's Wise or Unreal's built-in solution. So I think this is a pretty flexible system. So we have the audio management section down here with audio curves. Audio curves are entries for sounds that it will dynamically create an audio component for you to apply curves and or other settings to. Let's make main engine thrust sound. Cool. And we'll use the power curve for the volume. And so you don't have to put a curve into any of these sections. If you do not have a curve, the volume defaults to the engine output value, which is already driven by the power curve. So we really don't even need to add that. The pitch curve defaults to a constant of 1. And then you just need a sound to manage. So we should have main engine. There we go. And you have the override attenuation settings. It'll either, if you don't have those checks, it'll use the attenuation settings assigned to the audio cue. Otherwise, you can set custom settings, so we'll do that real quick. Set this to 200, and then the maximum distance to 25,000. Because it's an engine, you can hear it from far away. Then we want to attenuate with low pass filter. Yes. Set this to 10,000 for the minimum, 25,000 the maximum. Pass filter at min, 50,000 and 1,500. Occlusion, so if the sound source passes behind something, it'll sound muffled and won't be able to hear it fully. We'll set that 1,200, 1,000. And set the interpolation time to something a little larger. Save that, file it. So let's see if this now works. Okay, I go change our engine to online and set our desired throttle. There we go. Cool. So that worked as intended. We now need to go to, we can add a new audio curve. We'll call this, I have turbine whine. I kind of wanted to use it as like a boost pump sound. So like the boost pumps spooling up to provide propellant for the engine when it turns on. But we'll just, so it's like a high-pitched turbine noise, kind of like a turbo would sound in a tuned car. So I have two presets, so we'll use turbine whine volume, turbine whine pitch, sound to manage turbine, high whistle. Yeah. We'll set the attenuation settings for these to be a little smaller. 100, and then we'll do 12,000. Actually, less than that. You should only really hear it if you're like right next to the ship. 6,000. We'll do some attenuation. 100, 1,000. These are just kind of arbitrary values. I don't really know what I'm doing. Don't judge me. We'll enable occlusion as well. We won't use complex for that. We'll just use normal. Cool. Let's take a look at the turbine whine pitch curves. So I'm going to adjust this a little bit. I kind of want it to be higher pitched earlier on. There we go. And its volume starts out high and like slowly gets drowned out by the engine. That's the effect kind of looking for. So we'll see if we can hear it. It should work. Should hear something. I believe I need to drag in the engine to get this. Yep. Go. And here is, fingers crossed this works properly. Set the state to online. There we go. Now there's a light whistle down at the low end. That's a pretty... There we go. Yeah, so that was pretty much all you had to do to set up a new engine. You know, there will be more features and functionality added to this. We're gonna need things for handling damaged and destroyed states and stuff like that. But the next step is making the engines spawnable on these ships and hooking them up so that players can actually use them to move around. That shouldn't be very hard. I've done a lot of the framework for that already. But yeah, just again, let me know how you feel about this configuration, and if it seems like it's easy to use. And if you have any questions, comments, or anything, just yeah, send me a message or whatever. But yeah, see you later.